Thanks everybody for tuning in today. We're nearing the end of this year, so this is going to be the second to the last talk that we'll have in this series for 2020. A lot of talks this year. We had 30, which is a record, sort of a function of us all being stuck at home and not being able to do these in person at conferences. So I do welcome people to go and look at the YouTube channel if there's topics that you wanted to see that you may not have seen live. Today is going to be our second attempt to schedule this talk because we had a catastrophic incident that prevented it from happening last time. But this is going to be our good friend Ed Colone from the University of Michigan and perfSONAR talking about a much anticipated topic that a bunch of people emailed me about this year, provisioning perfSONAR infrastructure with Ansible and the experiences that they had at Michigan. So hopefully this is useful for people as you are starting to get this installed at your universities and labs and regional networks. As a reminder, use the chat if you have questions. I'll gladly interrupt Ed as he's talking, and I will turn it over to you, Ed.
Thank you, Jason. My name is Ed Colone. I work for Dr. Eric Boyd, who's the director of our networks here at the University of Michigan on the perfSONAR project. The University of Michigan is a member of the perfSONAR consortium, and to that end, we contribute development and managerial resources from our institution back to the consortium. I'm going to talk today about how we automated the provisioning of perfSONAR here at the University of Michigan with Ansible, and how we and other consortium members have come up with a solution to a solution that's applicable to other institutions as well. So I'm actually gonna do something a little unusual to start here. I'm gonna be running a demo today, and there's going to be a very long step of the demo, and I'm going to start it now, and then we're going to return to it. So I would like to start off by showing you I have a terminal window open, and there's absolutely nothing in this directory. So I'm going to show you that what I'm going to do is I'm going to clone from GitHub the Ansible perfSONAR playbook. And you can see that that now exists. So we're going to go into there, and I'm going to do an Ansible Galaxy command. This is going, I will get more into this later, but this is going to bootstrap the roles for us. If you can see that it went through the different pieces of perfSONAR infrastructure and loaded the roles. And now I'm going to type Vagrant up. So part of the talk today is going to deal with Vagrant, which is a virtual environment. And as you can see, it is importing CentOS 7 to be a virtual machine for the Esmond Archiver. And this is going to take some considerable amount of time. So we're going to let this work in the background while we talk about how to accomplish the same thing. So anybody who's seen an iteration of my talk knows that I love this slide. This is very true in practice. In theory, you say, I have to automate these tasks to give me more time for my real job. And pretty soon, once you start automating things, your real job sometimes becomes automation. So it's kind of an irony. And let's see here. So what is perfSONAR anyway? perfSONAR is an entire system for generating, storing, visualizing metrics on schedules. So that way you can set a few perfSONAR nodes up in your environment, have them generate metrics on a schedule that you dictate. It sends them to the archive, and then you can visualize it and see how things are going. So you can kind of see right there on the left-hand side of this graphic, the admins for scheduled testing, the admins have an opportunity to either publish a schedule by hand or through the PWA graphical JSON publisher. You pick up those schedules for your MadDash and your test points and toolkits. It runs the schedule, puts it into the archive, and then it gets visualized. So you can see that there's a lot of different components and there's a lot of different interdependencies. So you can see here that the test points and toolkits must be registered with data archivers, or else they're not going to be able to write their data to them. The dashboards must be made aware of the archivers and the schedule to know how often to read it. So the test points and toolkits need to read the same published schedule. And then you need to be able to publish these schedules as well and make your componentry aware of it. So there are a lot of interdependencies. So at the University of Michigan, when I first started at the perfSONAR project a few years ago, we had a bunch of existing infrastructure, and since then we've only gotten more. We have core perfSONAR nodes near our main routers. We have 2 satellite campuses that have test points. We have multiple 1G and 10G mobile test points. So we provision them in temporary places in the field when we have trouble reports. We have an Esmond Data Archive. MadDash dashboard visualizes the information. We publish schedules both manually through PSConfig, and we have a PWA perfSONAR web administration instance here on campus. My job title is software engineer, not sysadmin. So in order for me to accomplish all of this, as well as being able to make software development objectives, there was no way I could do this manually like when we started. Instead, I had to figure out a way to automate it. So when I first got hired on, we did a manual upgrade of a 12-node cluster from perfSONAR 3.5 to 4, from CentOS 6 to 7. And it was quite the endeavor. It took 5 sysadmins 2 or 3 days to complete. And then once we had it in place, we were afraid to touch it because we were in a position where if we broke it, we bought it. Whoever messed up the working config had to figure out how they messed it up and how to restore it. And that might be trivial, or it might be a couple days worth of work. So when we got done, it became pretty apparent that for a modest amount of test points, takes a few days to install, and then to bring an archiver up takes a day. And it's not necessarily, the pain in some of this stuff isn't even necessarily installing the software. It's getting it configured and getting all of these different components pointed at each other in the correct manner. So when you see a day for an archiver or a day for MadDash, it might not take that long to install the software, but it might take that long if someone isn't familiar with how to configure it in order to get it to talk to the other components correctly. So we decided we were going to create an Ansible solution for installing perfSONAR. We decided on Ansible because it's an open source industry standard solution. It's agentless. We didn't have to install any extra software. It uses SSH. So you probably at your institution already have a strategy for managing SSH to your component infrastructure in a secure manner. So all you have to do is you have to have Ansible, piggyback on top of that. perfSONAR authors and supports official playbooks and roles. I'm part of that authorship team, but there are others. To get started, basically, you have to bootstrap the machine with your base OS of choice, your security patches and mods, your user accounts, and then you can use Ansible. So the other 2 things that Ansible is really good at is managing component interdependencies. And it is also really nice because you can use it to surface component options and config options. So that way, instead of having to go read through lots of documentation, you can just see that there's a particular switch, and enabling or disabling that switch has a particular action. To that end, once you have your hardware bootstrapped with OSs and accounts, you could have, once you have Ansible set up to talk to all these things, you could spend a few hours going through the various configuration options for how to configure perfSONAR via Ansible, and we'll go through that. But if you're unfamiliar with it, it could take you a while. It might take you 1 to 4 hours. And then once you have a config that you're happy with, depending on how detailed it needs to be, then you start to run Ansible. And Ansible at that point will take probably less than an hour to install and configure all of that componentry. So we've turned a week's worth of work into a day's worth of work at most. So we're going to talk about how we manage perfSONAR nodes with Ansible. We have a Bastion host, and that's the main checkpoint for security. It has two-factor. It has Ansible installed. That's where we manage a lot of the user accounts. Now, Ansible is incompatible with two-factor on target infrastructure. So the way we get around that is we require two-factor to get to the Bastion host, and then all of the component infrastructure is IP restricted to that host. So you need to have an SSH key on that infrastructure, and you need to have an account with two-factor on the Bastion host. So once you have that, you can go and get the commodity playbooks and roles. So you get those from perfSONAR. You don't have to write them. It's very easy to go get them. We'll show you that in a minute. And then what you can do is you can store your inventory, basically the configuration, in one or more repos of your choice. So at U of M, we have a couple of different perfSONAR installations, and each one of them has its own repo. So you just go fetch the repo. You can either apply it as is, or you can make changes and push it back. So it works as both disaster recovery and version control, as well as being able to share your work with your team members. So we're going to talk a little bit about deployment strategies now. So perfSONAR comes with two sort of probe types. One of them is a test point, and one of them is a toolkit, and we'll talk about the deployment strategies. So if you're just getting started with perfSONAR, it might be attractive to get a toolkit to mess with. The toolkit is for smaller installations, just one or two nodes, but it has a little extra interface on top of it. It has a web graphical user interface. You can use that for ad hoc testing in order to tell it to run a test in real time. You can use the web GUI to do some limited scheduled testing. And instead of having to deployment with Ansible, you can just install the ISO. So the toolkit is really a standalone, one node perfSONAR experiment. You can use that to get yourself up and running and experiment with it. But once you start to try to scale perfSONAR, it quickly becomes a good idea to abandon the toolkit in favor of a test point. The reason for that is, it has less overhead with the web GUI and everything else. But when you use that web GUI to create schedules, it creates volatile data on the toolkit in the form of a schedule that if you want to preserve, you have to back up. So suddenly that node, which has non-volatile data, you have to have a backup strategy and whatnot. So the way that this talk's best practice works is we're going to deploy test points, and we're going to have the test points refer to schedules on schedule publishers. So the schedule publishers become a repository of unique schedules. If you want to back up them, you have a one-point backup, and you're not deploying toolkits, you're deploying these test points, which then go read these schedules instead of storing them locally. So target OS bootstrapping. Today we're using CentOS 7 and Ubuntu 18. They're both official perfSONAR OSs. They have configured network and DNS. They're secured, and they're locked down. So in fact, some of today's demo is going to be done with Vagrant. So they're actually contained on a machine. So that's going to be part of today's demo. So the Ansible playbook itself lives at the top URL, the perfSONAR URL on GitHub. And it provides a quick start instructions and a script to create multiple inventories. There are roles associated with this for each component. The developers have created the roles. They're kind of abstracted away from the end user. Hopefully, if everything goes well, you're going to be able just to get the playbook, bootstrap it with the roles. not really care too much how they work, and just utilize them. So we're going to talk a little bit about Ansible task delegation. One of the powers of Ansible is when Ansible controls your entire component infrastructure, it's able to enact certain component interdependencies. For instance, we talked before about how Testpoints want to have write access to archives. Using delegation, it's possible while you're provisioning a test point to ask that test point for a list of its IP addresses. And then during that provisioning, if you control the archive, you log onto the archive and you enable them through the test point role. The same mechanism exists if you publish schedules on a schedule publisher. You can push those to test points if you control the test point. And the same thing with dashboards. And this is just a high level view of it. We're going to talk a little bit more about this in depth. When you provision the components, the first thing that we're going to provision is archivers, because the next thing we're going to do when we provision test points and toolkits, they have to auth themselves to the archiver. Dashboards, they have to, they get provisioned, and then schedule publishers. So there's a rolling provisioning system based on which component needs to exist first in order to have the other ones interact with it in the right order. So we're going to talk about Ansible inventory. Inventory is really where you're going to spend most of your time. The inventory is a file structure which describes how Ansible should configure each piece of component infrastructure. And one of the nicest things, like I said before, is you can store individual inventories in source control. So if you blow up your site, you can just get another Ansible controller, you go get the commodity playbooks and roles, and then you download your inventory and you're back up and running. We've turned our perfSONAR disaster recovery plan here at the University of Michigan as a single page, just to give you an idea. So there's variable precedence. When you define an action you want, the less specific area that you define that has the least precedence. So you can see that you can have a group variable which is overridden by a host variable. So if you have a series of test points and one of them is special, you can give that one a special config file and that will override the master. So that's a good example there. If you put your things in group vars, that has less precedence than host vars. So if in the host vars directory, you created a host name and you put in some YAML files, they would, whatever directives they had would be higher precedence. So there is a hosts file itself, and you can do things in here like manage connection variables for all the hosts. And then you can also define individual hosts to have component infrastructure installed on it. So for instance, test points and toolkits are the probes, archivers are the data archives, MadDash is the dashboard, and psconfig publishers and psconfig web admin are the schedule publishers. Now, if you look at the way perfSONAR bundles are handled, you see that there's the central management bundle, which bundles MadDash, the archive, and psconfig all in one. We actually do it in an a la carte manner. So you don't have you can actually have performance problems running, a lot of this stuff on the same host. So it's better to break it up where your archive is in one, MadDash is on the other, your publisher's on yet another one. And by doing so, you have better control over your resources. And if one of them needs more horsepower, you can just focus on that one. And you don't have to install the central management bundle like you do with the bundle install. So the easiest way to get up and running is to use an Ansible local inventory file. You basically just put it in the inventory and have it run. But what I prefer, and as a better best practice, is a shared inventory, where you might have an inventory for your site that describes all of your machines. And you might, before you run perfSONAR, run your institutional Ansible Bootstrap against it. So you might be able to install security patches, manage accounts, manage connection variables, things like that. And then when you then you can reuse that same inventory and have perfSONAR run against it so it knows what components go where, and you can store that entire inventory in source control for disaster recovery. So when you do a Bootstrap, you install the following roles, and these are all going to correspond to different pieces of perfSONAR infrastructure. So the roles have a concept of inheritance. All of the roles will inherit the installer. So the installer knows how to, set up the right repositories and how to install, software. And rather than do that 7 times in each role, we just put that in the installer. Now, all of the other roles inherit that and use it to install software. The toolkit is, like we said before, is a test point with some web GUI on top of it. So if you decide that the way you want to do this is deploy a toolkit, you can. And what it's going to do is it's going to inherit all of the test point configuration as well. So the toolkit special sauce is just the GUI. You basically manage it the same you would as a test point. So let's talk about the installer role real quick. You can have it install base OS updates. It configures the repos and it installs the software. If there's any additional dependencies or packages, it will install those for you as well. For the most part, this role is abstracted away from you. Really, the only option you're going to be interested in is whether or not you want it to install your OS updates. The archiver, and we're going to talk about this in a little bit as well. We have an evolving nomenclature. We're going to start depreciating certain legacy pieces of software in favor of more modern solutions. So before we made that decision, Esmond was our primary archiver. So it was traditionally called the perfSONAR archive. So later on, this is going to transition to Esmond, but right now it's just generically referred to as the archive. Basically, this configures Esmond for perfSONAR. And if you look at the role itself, you can provide a static list of IPs that are allowed read or write access to this database. So let's talk about that. We have some test points and we have a database and we want the metrics to go into the database. So if you manage the Esmond archiver, let's say you don't, let's say another institution has an Esmond archiver or somebody else that you don't have access to has one, and you want your test point to be able to write to it, that's an out-of-band operation. You have to provide the IP address that you want to the administrator of the Esmond archive, and they have to manually add that IP address for it. There's no getting around it. So if you manage the Esmond archiver and you don't manage the test point, you can add the test point's IP address to the variable perfSONAR archive auth list. We'll see that in a little bit in the PS archive YAML file. If you manage both of them, then you can actually have the test point query itself, pull its IPv4 addresses, and then delegate a task to the archiver to say, yes, give me write auth on these IPs. So that's the part where you control both ends. Now, the test point is the most major role. Generally speaking, institutions that run perfSONAR run multiple test points. We have like anywhere between a dozen or 2 dozen. Other institutions have upwards of 50. So this is a really kind of the workhorse role. You can optionally include some of the toolkit packages like the NTP package and security package and other packages. The role allows for that pretty trivially. So it also does other things to prepare the test point, make sure that Etsy host is in order. It allows you to configure NTP servers. It optionally disables root SSH access. If you have any remote schedules that you don't control, you can add them statically here. You can, like I said, there's that delegation where you can have this thing delegate its IPs to archivers. And then there's some troubleshooting mechanisms involved too. Like you can check to see which processes are running, and you can run pscheduler troubleshoot to verify that pscheduler's in health on there. So if you have a test point and you want it to follow along with one of the JSON mesh schedules, it's going to be a similar operation where you say, do you manage the test point? No, you don't. So if you don't, then you have to contact that test point administrator and tell them, hey, I want your test point to participate in this mesh. Here's the URL. And that's the old-fashioned out-of-band management way. Now, if you don't manage the schedule publisher, but you do manage the test point, you can go into the PS Testpoint YAML file and add the URL that you're of the schedule that you want manually there. It's a static URL. You go ahead and you add it. Now, finally, if you manage a bunch of test points and you manage a PWA or PS config publisher, you can add those test points to the PWA file or the PS publisher file, and it will push the schedule to them in a delegated action. One of the nice things is you don't have to add them individually. You can just use a group. So here's an example where you can say in the PWA config file, please apply all the schedules to all of the test points, all of the dashboards, and all of the toolkits that you know exist. And then once you do an update, it'll just push it out again. So the toolkit we talked about, it's basically the test point with a web front end. This is really for very small installs. We're not going to go. It's kind of not the model for this. It doesn't fit this model great. So we're just going to mention it's possible, but we're not going to really do a lot of toolkit deployment. MadDash is the visualizer that uses the Esmond database. And the role here basically starts the MadDash agent, and it can manage remote meshes. So, or ingest remote meshes. And once again, it's much the same thing. If you want a MadDash installation to display a mesh and you don't control it, you have to contact the admin of that MadDash, and you have to provide them the JSON URL and hope that they add it. If you own the MadDash, but you don't own the schedule publisher, then you have to change the PS MadDash YAML file to include that static URL. You can add it. Now, once again, if you own the whole thing, if there's a schedule published by PS config or PWA, there'll be a delegated action where it will push that schedule to MadDash if you instruct PWA or PS config to do so via the PS publisher or PS PWA YAML files. So the JSON publisher, this is a real simple role. It basically just takes a raw JSON schedule, publishes it, and can optionally push that to one or more test points or visualizers. And then PS config web admin is where you have the graphical ability to make a schedule. And this uses Docker and some containers. There's a concept of a user management, and we have that done in Ansible as well. I'll show you that in a little bit. And I'm going to talk about how to implement all this. So the first thing you're going to do is you're going to clone the playbook. You're going to go into the playbook, and you're going to bootstrap it with the Ansible Galaxy command. So now you've got a playbook, and now you've bootstrapped it with all of the roles. The roles are all the components that we just talked about. Then what we're going to do is we're going to create a custom inventory for our site. I use the very creative name Ansible Inventory Example. Your mileage may vary. So if I ran the defaults.sh shell script and included in the playbook against a non-existent directory name, it's going to create that directory, and then you can see that it populates it with a hosts file, optionally the host vars directory, and then it populates the group vars directory with all perfSONAR and the perfSONAR YAML files, which we will use to control the installation. We touched on what each role did. there is a one-to-one reference between each one of these YAML config files and a particular role. So if we wanted to override the group vars, we would create inside host vars, we would create a directory for the name of that host. It will have to correspond to something in the host file for it to be recognized. And then you can put different YAML files in there. So this would be an example of how you would copy lsregistration.yaml into a directory, so that way you could talk about that host for the ls registration. And let's say you've got a global, let's say this is a test point, and you want to override some of the global settings that you have in the group vars. You can put that here, and you can either just have the variables that you want to override, or you can have them all. So once we run the playbook, there's really two commands that are used the most. The Ansible all -m ping allows you basically just to verify that Ansible can log on to all of your infrastructure. And if you have elevated permissions for Ansible, that it can attain them. And if there's an error between your Ansible controller and any of your infrastructure, that's a quick way to find it. So, just making sure Ansible can do its job, talking to the infrastructure and getting the right privileges. Once you are satisfied with your configuration, you can go ahead and run the Ansible playbook against the perfSONAR.yaml, and it will apply the roles to your infrastructure with the configuration that you've chosen in your group or host vars. So one of the things about Ansible that is maddening is it sometimes is a bit confusing to manage different connection variables. They have a facility to do so in the hosts file. You can even do it on a per group or a per host level. But I've discovered in practice that if you mix command line connection options with stuff defined in config files, even though Ansible says that there should be a strong precedence, sometimes crazy things happen. So in my own practice, I tend to not define connection variables in config files. I tend to always expressly say them on the command line. So one of the things that we always require is we need to become root. So you're going to have to say become and become user root. There's a become method. Either your machine is set up so that your user that you're coming over as logs on and either attains privilege by su or sudo. You can say that here on the command line. If you don't have an SSH key and you have to ask for a password, you can say ask pass. Once you're on the machine, if you're using su and you need to have a password, you can say ask become pass, and it will prompt you for that. The user could be defined. So by default, it goes over the SSH connection as your user ID. But if, for instance, you have some strategy where there's a common Ansible account, you could use say user Ansible. So we talked about default and extra inventories. You can tell Ansible which inventory you expressly want to use with the inventory flag. You can limit your run. So let's say you only wanted to provision archivers, or only wanted to provision test points, or even wanted to provision just a machine. You can put a limit there as a machine or a group name, and it'll only run provisioning against that. And finally, some of the tags in the perfSONAR roles are things like, perfSONAR install, perfSONAR configure, perfSONAR troubleshoot. Let's say you only wanted to run, the troubleshoot part. You could say tags troubleshoot, and then it will only run that portion of the script. So let's take a quick contrast. We talked about how our legacy manual install could take upwards of 5-6 days, and how our automated deployment could take, a half a day. And we have them sort of juxtaposed here, where you can see the automated deployment overlaid on the manual deployment. and see what kind of a time savings that might give you. Now, one of the other things that we've started using recently is Vagrant. I started this talk by downloading the playbook and bootstrapping the roles, and all I did was run a command that said Vagrant up. And what this is going to do is create a virtual dev environment for me to play around in. And you can, in today's demo, you're going to see that it's a really simple environment that we create. And we have an Esmond archiver, and we have two test points. One of them is a CentOS 7 test point. One of them is Ubuntu 18. And you can see that in the Vagrant file, there's directives about which OS and how to provision it. And we'll get into that. I'll show you the example that this example comes with the playbook right now. So you can see one of the things in Vagrant you can do is you can enact the perfSONAR Ansible variable declarations, and you can define and override them. So here what you can see is in the Ansible section, all of them, all machines, you're going to need to be able to become root, and the method is sudo, and we don't want to update the OS. We just want to say false on that. So then you can see that we've defined a group of test points. One of them is called CentOS 7, one of them is called Ubuntu 18. And inside there, what we're saying is we'd like to say the archive auth interfaces, so all the interfaces we want to have write access, consists of all the IP addresses on IPv4 addresses on that particular machine. And you'd like to delegate that write access to a group called PS Archives. So you can see beneath that PS Archives is the Esmond host. And so this is a very simple config that overrides the generic config with these options. And we're going to see how this plays out in a few minutes. All right, so I'm gonna switch now over to the okay. So this right here is the output of the Vagrant run. So you can see here that when we first started, when I typed in those commands, it got a machine image. So it got a CentOS 7 image, and then it went and it installed the archiver on it. Sometimes Ansible's output is a little incomprehensible. I generally tend to look for color. If I don't see red, I know I'm doing okay. You can see here it installed a bunch of packages for us. It did all this in the background while I was talking. We didn't configure the LS registration, so it skipped those. But you can see, let me see if I can find, all right. I'll show you what I'm looking for here. If I can find it. One second. So right here, auth interfaces with measurement archive. You can see that it did the delegation that we asked. It changed, even though this is the test point role, not the archiver role, we can see that it interacted with the archiver because we controlled both, and it added the IP address of this test point to the archive. And it's a little incomprehensible, but you can see here by the color, it certainly does look like it worked. So now we're basically gonna, at this point, test the install. So if we take a look at the Vagrant file, we can see that we have 3 machines. We have the Esmond machine, the CentOS machine, the Ubuntu 18 machine. Down here, we select the OSs. You can kind of leave all this boilerplate in here untouched. And if you want to play around and simulate your own install before you try it in production, this is where you do the variable declarations the same way you do as an Ansible inventory. So you can see here that we had 2 test points and we have an archiver, and the test points should have authorized themselves to the archiver. So now we're going to do a Vagrant SSH to Esmond, which is the name of our archiver. And we're going to do a user Esmond. Oh, can't do that unless I'm root. So we did a Esmond manage command, and we wanted to list the user IP addresses. And as you can see here, we got 10.0.0.3 and 10.0.0.4, which corresponds to the test points in our Vagrant file. So we can tell that we have a virtual archiver, and our virtual test points are allowed write access to it already. I'm going to pop out of the archiver, and I'm going to do a Vagrant SSH over to the CentOS 7 box. And I'm going to do a pscheduler task throughput to Ubuntu 18. So one of the other nice things, well, I'm going to talk about this while we wait. One of the other really nice things about this is if you are testing changes across multiple operating systems, you can use Vagrant to pull down, that specific OS version as an image and then apply it. So right here, you can see that for various reasons at the University of Michigan, if we have an x86 processor, we're going to run CentOS on it. If we have a bare metal ARM processor, Ubuntu 18 is our OS of choice. So you can see here that we can use those 2 images and install things on them in this virtual environment, and then see that it actually works. And you can see right now that internally, this machine with this particular configuration got north of 3 gig between the 2 virtual machines in the configuration. So that's sort of the Vagrant side. I'm going to show you actually. So here I am in the playbook that we've been talking about. I'm going to do a VI of you know what? I'm actually going to show you a live inventory for a project that I'm working on. Whoops. So if I did so I'm gonna quit out of this. I'm gonna say ls minus l that path, or ls that path. How about that? So you're able to see that inside of this playbook, I've got an inventory stored in source control already. Ansible inventory net bassless perfSONAR. This is one of our working projects that we have a discrete inventory for. And if you do an ls of the inventory group vars all perfSONAR, you can see the individual config files. So I'm going to quickly go through those config files. All right, you can see here that we have an example of a static archive. So we have, this is the archive list for NetBasilisk. We do not control the 192 host, so we added it statically. And we said state's supposed to be present, and the user to identify it with in Esmond is AGLT2. That's a good example there. This is the PS installer. Like I said before, really the only thing that you're going to play with in here is the perfSONAR OS update. Other than that, you pretty much shouldn't mess with it unless you have something specific you want to do in your developer, like getting a nightly release. But for the most part, most people are just going to either change OS update to false or true and carry on with their lives. So this is another example. This is the MadDash. You see that it's picking up a URL. This is a static URL that MadDash is picking up. This is the MadDash YAML file. Here's the psconfig publisher. You can see right here that we're not actually publishing any meshes off of this machine, but if we were, they'd be listed down there. There'd be a URL, there'd be a remote directory, and then you could put in the remote agents. And you see that it comes pre-populated. So if you wanted to add it to all your schedulers, or excuse me, all your dashboards and toolkits and test points, you can just comment that out. And configure archives needs to be true in order for those test points to try to send the material to an archive. This is PWA. The top part of this stuff you don't really need to mess with. It's sort of just path names that are mostly standard. The thing that is really nice in PWA is you can do user management. Like, so for instance, right now, you can see that we have on this project a couple of people. I'm sure some of the names might be familiar. And you can see that when we provisioned these identities were provisioned with default passwords that they were then asked to change, and they were offered a user and admin scope. If you start provisioning PWA and you want your users to be able to log on, you can either do it by hand or you can manage the list this way. The test point. This is the major role. You can see that there's optional packages that we include by default. There's a place to manage the NTP. And then this remotes stanza is where you can put in static URLs for schedules that you'd like your test point to pick up. There's the auth interfaces stanzas. This is for doing the delegation between the test points and the archives. This basically, if you control the archive on the test point, you can tell the test point, yes, please apply my IPv4 addresses to the archive. And then down at the bottom is below that, you really don't need to change anything because that's just for management of services. This is the GUI management for the toolkit on top of the test point. If you have a toolkit, the toolkit will be managed to the test point config file as well as this one. And that's it. So once you've done all that, you can do an Ansible Playbook command to apply those. Let me show you a couple examples in NetBasilisk here. I've got a README file here, so you can see that. For instance, if we wanted to display the auth archivers, we just scrape this stanza, and you can see that we're running a command remotely. We're telling it we need to ask the password and we need to become root. So I'm going to try that right now. And you can see that Ansible went out, logged on to the remote machine, ran the command, and returned to see that, what was on there. And you can see indeed that our AGLT2 stanza was picked up when we provisioned this. So this isn't very exciting because obviously it's only talking to one machine, but if we had multiple archivers, it would have done this across them. And if you want to run this command over your entire, like if it's a test point command, you could run this across, as many test points as you had. So let me go back to my deck here. So our next steps. Generally, right now, our nomenclature isn't consistent, so we're going to change some variable nomenclature in the future. So if you have a working config and it ceases to work, maybe some of the directions will change. We're going to enhance our Vagrant and Docker support. You saw a little bit of the Vagrant. We're also going to try to do some of the same things for Docker. We're going to improve our documentation. We're going to bring the versioning of the Ansible stuff in line with the rest of the perfSONAR versioning numbers. We're going to provide enhanced troubleshooting. You're going to be able to use Ansible to log onto these machines and get system metrics. So you'll be able to gauge the health of your probes. We're gonna improve the checking of interdependency connectivity. For instance, we're going to make sure that your test points can do a request to the archiver, that your dashboard can request things to the archiver, that the test points can talk to each other. We can run some of those tests through Ansible. And we're also, right now, we're doing process checking for test points and toolkits, but we're going to add that to all of the roles. The test point, right now, we don't have very good support for optional pscheduler tests and tools. We're going to add that. There's been a lot of interest in not just installing pscheduler the traditional way with packages, but rather using Docker. We're going to support that in the future. And now that a lot of the Debian stuff has moved towards Crony, we're going to support Crony along with NTP. In the future, there's going to be emerging standards. Esmond might be depreciated in terms of ELK. That's going to be a nomenclature change, as well as requiring us to develop some ELK expertise and roles. And then MadDash might be depreciated in favor of Kibana and Grafana with the same implications. We have started a bi-weekly automation meeting. I have a conflict for next week's, but other than that, we do them pretty regularly. If you'd like to be involved, please contact us. We'd love to have you. And I'd like to give special thanks to everybody involved, the perfSONAR development team, especially Mark Feit, Ivan, and Antoine, who are my other authors of a lot of the software. The U of M networking staff for letting me do crazy stuff on their networks, and Katerina Thomas, who makes these slides and always makes us look way more professional than we really are. So that is the conclusion of my slide deck and my demo. So I would like to take questions at this time if there are any.
All right, well, thank you so much, Ed. We don't have any right now, but for people who do have questions, please type them into the chat room. I say, if possible, pull up the GitHub link, because people will probably ask to see that again. I have a couple that I jotted down that I'll just start us off with. So, you of course started with your XKCD time versus effort graph right there.
Indeed.
How much have you sunk into this at this point? For somebody who's getting started with something like this, expectations and realities are important. So how much time did it take to sort of learn the infrastructure, and what are you looking at now for what you've actually sunk in versus what time you're saving?
I've sunk in an embarrassing amount of time developing this, but the way I describe this to other groups is that there are different levels of Ansible expertise. I look at three ways. There's Ansible users, and if you want to just use this stuff, we've already taken the pain points for you. You can go get this stuff. You can just make sure Ansible can talk to your infrastructure. You can configure it and you can run it. If you are starting from the ground up with a moderate amount of Unix sysadmin knowledge and almost no perfSONAR knowledge, this could be your reality. You set up the OSs, you get the playbooks, you read through the config, you make sure Ansible can talk in the component infrastructure, and then you just run it. This is conceivably a 1 or 2 day exercise for an like intermediate Unix admin with novice perfSONAR experience. I took the pain so you don't have to. I've sort of made this an area of my expertise. So now I kind of do this as a function of a developer at the perfSONAR consortium level. So that's the next level. You kind of like author roles and playbooks. You don't have to do that. It's commodity. It's been provided to you, as well as the inventory file structure that's been provided to you as well. Just get that and use it. And then one level past me is there's another developer level where you start to develop native Ansible modules in Python and things like that. And I haven't even had to go there yet. So We've done the Ansible role and playbook development. We've given you the inventory structure. Go get it. Make sure it talks to your component infrastructure. You'll be up and running in a day.
Okay. And how many did you say that you are deploying right now within your campus network via a system like this?
So we've got a dozen mobile nodes that we all configure like that in one inventory. We have the NetBasilisk project where we configure a bunch of infrastructure with that. So I'd say like multiple archives, multiple schedule publishers, and then our core test points, we have about a dozen around campus. And then we also have some experimental projects that use perfSONAR for other things, like Wi-Fi monitoring as a component, and we manage all that with the same Ansible roles. So I would say we manage dozens of test points and multiple archives, data publishers, dashboards, things like that. Once I've deployed single test points in environments, and rather than do it by hand, I actually, even though it's a single test point, I use this because it doesn't make mistakes like I would. It doesn't forget to do things. All I have to do is add the test point to the inventory file, make sure I can connect up and I can have root, and then I just let it run. So this is scalable from 1 to n. So
Okay, and that leads into another question that I was sort of thinking. So, naturally, this is good if something dies and you're able to reconfigure it really quickly. Um, were there any sort of self-inflicted wounds as you were getting going with this? I mean, we all have horror stories of, oops, I messed up a config file. How easy is it to shoot yourself in the foot? And are there training wheels available for people who may be afraid of such things?
uh, basically, if you color completely in the lines, given the playbook and the inventory that we've given you, I mean, you could mess up some configs, but you're not gonna like rm minus rf, slash or anything like that. If you just stay within the bounds of the parameters that we provided, it might take a couple tries to get your config perfect, but you're not going to destroy anything along the way.
Okay. Steve has a question. Using Vagrant on moderate desktop-like hardware or laptop, is it conceivable to run an entire develop environment that would allow to test campus-wide deployment?
So the machine that we did the Vagrant demo on today was a 4 or 5 year old Dell 1U server that I think has 2 processors, and it's a modest machine, and it managed to handle the demo. I have noticed that if you add lots and lots and lots of machines, then you can end up with hardware performance problems. Um, I would say that if you want to simulate 30 test points, a desktop might not cut it. But if you wanted to simulate, one archiver and then one test point for each OS that you're interested in, then that's more than sufficient. If you want to start scaling to like 30 test points, you're going to need something with some horsepower. I've noticed that. So I had 2 interns working on Vagrant on the same machine, and they could conceivably at different times step on each other. If both of them did a Vagrant up, then sometimes the machine would grind to a halt. So Vagrant is not, it might be free as in cost, but it's not free in terms of horsepower.
All right, good to know. And Mark noted that perfSONAR was deployed on Sinet last year when there actually was a Sinet. So good to know that as well.
Jason,
So
can I make a comment about that?
Sure, go ahead.
Yeah, one of the things that we did that we did last year with it, all the development was actually done on my laptop. So I had sort of a simulated Sinet deployment on my laptop. So I was able to iterate through that without having to have access to the actual infrastructure. So when we went to install it, all we did periodically was as a new test point came up, because the places where the test points were being built were not all up at once. All we had to do was just rerun. Ansible, and it would take care of finding any test points that were not properly configured yet, and would get them fully configured and running. And it was literally just one touch to do it.
I believe that the most flattering comment that I've gotten so far was from Mark Feit. He said that by using Ansible for the Sinet install, it let them concentrate on harder problems. So it shifted from a provisioning and configuration chore into something where when they had deeper issues, they had time and cycles to be able to debug those instead of having to just manually do 30 test points.
Yep. Yeah, that's a perfect comment. So we'll pause there again in case any last minute questions, but I'll thank Ed and Mark and the perfSONAR team. We share the link to the GitHub repo in the mail and on the YouTube page when this gets posted for people to download and try it, and certainly report bugs and make it better. That's the only way that we get this stuff working for the community.
And if anybody out there wants to adopt this solution for their institution and you want a little bit of hand holding to get you off the ground, I've been known to participate in such endeavors. So if you want to reach out, let me know. And if I have some cycles free, maybe we could get on Zoom and we could get you started.
All right. Well, thanks everybody. Just as a programming FYI, we will be off for a couple weeks because of virtual supercomputing and virtual Turkey Day. We're going to have one more talk, I think on December 4th, with Jeff Handel from Cisco. And he'll be talking about something IPv6 related. And then that'll be the last one of the year. So hope everybody has a good couple of weeks off, and we'll talk to everybody soon.
Thank you so much, Jason. We appreciate the opportunity to show our work.
Thanks all.